Alrighty, now that we have this new paradigm, we could start playing with it like a kid on Christmas. Um, when we build something like this, an invention, we have to borrow parts from other machines, and so that's what we've done here. And in the case of life, uh, life spans every human discipline, so we need to borrow parts from each of them. And you know, uh, some of these parts are more valuable than others. We've talked about Einstein. I mean, he gives us these parts that are essential. Life is a function of the universe. If we don't have a good model for the universe, then we can't understand life. Um, Quite obviously, we need Darwin. We need to understand what Darwin did. He didn't invent evolution. Evolution was around for a long time. What he did was he made it mathematical. Okay, and he introduced this algorithm, which is a purely mathematical algorithm. It's an algorithm that generates complex sets of multivariant parameters. So, it's not a simple linear thing. It's ironic that they ended up using it as a tree of life because that's wrong. Life is not a tree, it's a network, it's a complex network. The genetic code itself is a complex, perfectly symmetrical network of information. So we need to start thinking in terms of spatial symmetry and, more importantly, in how it's broken. This is what creates the information. Okay, it's the complex network. It's like a neural network. So the math that Darwin invented, which works as the foundation of all life, that needs to be extended. It needs to be explained. So we go from this algorithm to this actual mathematics. Now we have a fully formed mathematical idea. Now, this requires a lot of mathematical intuition. It's not the kind of math that you're used to. But you got to realize that the kind of math we're trying to form, that life is actually generating, is a complex, nonlinear, non-Euclidean field. Okay, that's what gravity is. That's what quantum physics is. That's what life is. So we need to imagine this kind of math, and that's exactly what Darwin did. He says, look, you can generate this with a genetic algorithm. And he didn't have the kind of mathematical sophistication to speak in those terms, but that's exactly what he did. So it's that genetic algorithm that we use in neural networks for machine learning. That's how all machines learn. It's a genetic algorithm. So you have to create a set, select from the set, use the set you just created to create a new set, select from the set, use the set. Okay, so it's an iterative self-referential process. It's a fractal. And we can see this mathematics. We can visualize it with literal curves. And we can create fractal curves. And we can imagine life is a fractal curve. I mean, the whole point of life is to position atoms in space through time. Okay, but it's doing this in an incredibly sophisticated way. I mean, this thing's the most beautiful thing you'll ever see. This code is the most beautiful. It's so elegant and so powerful. It's like Grace Kelly or Scarlett Johansson or Anne Hathaway. I mean, it's just beauty incarnate. And so if you don't see the beauty of it, then you're looking at the wrong thing. This is an incredibly elegant, logical mathematics, and life is building it one atom at a time. It's literally plotting out itself. It's a self-referential, self-organizing code. It's building itself. So we can actually visualize this process in space through time. So we need to go back and say, what are our foundations? Well, Erwin Schrödinger just nailed it. I mean, what he said is exactly right. It's an aperiodic crystal, okay? It's feeding off the opposite of entropy. Okay, well, that's close. It's actually feeding off entropy. You need to have a sophisticated understanding of entropy, which is what was provided by Claude Shannon, the mathematical theory of communication. That's exactly right. That's what the genetic code is. It's a language. These molecules are communicating. It's perfectly mathematical. And it's entropy. And if you don't understand entropy at all, if you don't use it for your model, then you're going to be flying in the dark. Okay, so you gotta You got to have this. Schrodinger says, look, if we can understand how this works from a physics and math standpoint, we'll understand the human mind. Well, that's exactly right. And the guy who's, I think, who best captures that idea is this Graham Cairn Smith, Alexander Graham Cairn Smith. And one of my biggest regrets is that I didn't contact him while he was alive. I just wasn't, I missed the boat, I guess. Anyway, this guy, he was a Scottish chemist, biochemist. He was mostly just a thinker. He was brilliant. And so his ideas about the origin of life, I agree with those. His ideas about consciousness, I agree with those. The thing he was missing, he didn't have this. He didn't have this mathematical intuition. He didn't have the ideas of computer codes. If he had, I think that was the only piece he was missing, and I think he would have gotten it a lot closer. Well, when he talks about the origin of life, and he's talking about, he talks about a lot of stuff. But this transition from an inorganic world to an organic world. See, I don't quite share that because I think the universe is organic. I think the principles of the universe are the same principles as life, and I think it's a progression. It's a process. But then he talks about the evolving mind, the evolution of consciousness. In my mind, his description of consciousness is a better description of the origin of life than his description of the origin of life. I say that the origin of life is like the origin of consciousness. And I would go, this is an intelligence. I would say it's a consciousness. This is a network, a logical network, a complex logical network that's self-organizing, self-referential, iterative. It's using the genetic algorithm to do these miraculous things. And it's not just doing it in one place at one time. It's doing it as a complex code for all of life. This is the network language of life. So when you start to see what it's actually doing with these codons, you need to see the codons themselves as complex networks. And then the molecules that represent the codons are complex networks, where you just keep fractalizing this process. And before you know it, this thing's a predictive algorithm. It's predicting molecular behavior. It's causing the most highly improbable atomic behavior in the universe, but it's making it certain. So what it's doing is these smaller parts, the entropy is decreased. So the idea that you have 4 nucleotides, that's a low entropy set. There's only 4 of them, but it started with chaos. Okay, so it selects the chaos out. It leaves the low entropy. Same thing with the 20 amino acids. Same thing with the double helix. Same thing with the protein. So it's predicting the double helix. It's predicting the protein. The odds against it are long. So it does the same thing with ontology, okay? The first cell, the zygote, could become an infinite number of things, but it reliably becomes the adult male or the adult cat or the oak tree that have all these elaborate processes. They're highly improbable, but the first cell has a low entropy going to the 37 trillion cells. It hits the target every time because life is creating these nodes. So one node would be the set of 4 amino acids, or the 4 nucleotides. Another node would be the 20 amino acids. Another node would be you. Another node would be me. Okay, another node would be hemoglobin. So those nodes have to be hit with precision and reliability. That's a mathematical miracle, but it's hitting them in the same way that an artificial intelligence can, identify an image or identify a song or write a book. I mean, it's taking these improbable things and it's making them certain. It's decreasing the entropy at the nodes. Then it's compounding the nodes, and so we can visualize that as a single curve in space through time. It's the curve itself that's evolving. So the curve starts out, let's say, as a straight line, and then it just starts intensifying its curvature. It intensifies it by adding nodes. We could see that here, you've got 3 nodes. Now you have 6 nodes. You know, now you have, I don't know, more nodes. You have a lot of nodes. So the curve itself is becoming more curved, but the number of nodes is increasing, so the amount of information in the curve is increasing. And we can imagine that a crystal is a network. It's a field. Okay, so life is this all-dimensional. It's using every possible dimension of space, and it's creating this curve by taking symmetry and breaking it. But yet, because it's created by symmetry, there's still symmetry in it. So there's a symmetry between a cat and a human, that we're using similar pieces. They're not the same, but they're very similar. Okay, there's a symmetry between a bacteria at a suboceanic volcanic vent and us, and a blue whale and a flea. Okay, so these widely disparate nodes are just different nodes on the curve, but they're all using the same primitive nodes because those nodes have such low entropy, and you can compound them to generate more entropy. Darwin described this as a mathematical process that will evolve, and now we know the math. We know that it's a complex symmetry network. Okay, so when we see this thing operating over billions of years, this is machine learning. Well, it's learned these molecular behaviors. There's nothing in nature that's analogous to this codon table. Okay, the molecules don't have a table. They're not referencing it. They're not looking it up. Okay, these associations are more like a thought or a dream. Okay, the molecules have this dream that these behaviors will be reliable and complex and repeatable. So this is almost like a consciousness, almost like the brain of life. It's not dictating that A is lysine. It's predicting that there will be A at some point, and then there will be lysine at some point. But it's also predicting that there will be a protein or a gene after it's all mashed together, and then there will be a protein after it's all mashed together. Well, these are highly improbable atomic events, but they've been reduced to very low entropy, high probability. Well, we can go through and look at the pieces of this code and start to measure this kind of thing. Okay, now that we know what the math is, now that we can see what this code really is. Now, Schrodinger started us off on the exact right path, and then they discovered the double helix, and then they started crawling in the wrong direction. Okay, they were moving away from the truth. What they need to do is stand up and start running in the other direction. Okay, it's not a simple linear correlation. It's a complex, perfectly symmetrical, elegant, beautiful mathematical relationship. Okay, so we can start using this to do science. This is what science is. It's not just recognizing the paradigm, it's building the paradigm. And we need to borrow tools from everywhere. Physics, math, geology, chemistry, information systems, definitely information. This is a network. This is like a neural network. This is a machine. This is machine learning. Artificial intelligence teaches us natural intelligence. Okay, Darwin got us started by going from artificial selection to natural selection. He said there's an algorithm, there's a mathematical process. Now we need to extend Darwin. We need to say, what kind of math is it? Well, it's this incredibly complex field equation, and life is a field equation, just like gravity and quantum mechanics. Okay, it sits between the two, but it's every bit as complex. Now we need to start using mental tools to visualize how this field equation works, because life is literally inventing the math through the evolution of life. Okay, this math is getting more elegant and more powerful with each tick of the clock. Okay, it starts out with chaos and now it's ordered. It's a machine that's learned how to order chaos. Okay, and so we need to say, what specifically is it doing? Well, it's generating coordinates. So these molecules generate the coordinates of the double helix. The coordinates of the double helix generate the coordinates of the protein. So there's a language that creates coordinates from other coordinates. Well, these coordinates cannot exist until the molecules generate them. So it's a good thing that they're using a code that is the superposition of all possible crystals. I mean, that's what this machine does. That's what this code does. That's why I invented it, okay? I said there's got to be a code where we can create crystal points in space through time that are symmetrical. Well, that's this. Now life starts with this code, then it starts breaking the symmetry. It has a perfect symmetry, and with each molecule it places in that molecule represents a unit of broken symmetry. Okay, it's not a coordinate in space, it's a unit of broken symmetry. So the language itself is spelled out in units of broken symmetry. That's what a codon is. So a codon is a unit of broken symmetry, and then the codon table is a network of codons. So it's a complex logical relationship between codons. So all of a sudden, we don't actually need to imagine this happening because we can mathematically do it. We can trace the path that life took, okay? In medicine, there's this concept of doing procedures where it's see one, do one, teach one. Okay, I saw one, I did one, now I'm teaching one. Okay, nobody could have done this forward. Okay, I did it backwards. Every time I had to make hundreds of decisions when I did these things. Okay, and I kept getting stuck. All I had to do was ask life. So I'm reverse engineering life. There's hundreds of decisions. These things are hard to make. I had to make this damn thing from scratch. Okay, but at each step I had to make decisions. Well, that's exactly what life did. It's making selections from a set of possible choices. Well, each time it makes a selection, it creates information. And the set that it selects from becomes a new set of information. So there's this compounding of information that is naturally and logically derived from the breaking of symmetry. Okay, well, I'm not a trained mathematician. I'm very lightly trained. But these kinds of math ideas are sophisticated, but they're elegant because of the simplicity. So just imagine what a professional mathematician could do with this. I mean, this is who needs to be working on this day and night until somebody comes with a perfectly coherent story. I mean, I know that a lot of what I'm saying is wrong just because how the hell am I supposed to know? So this gets us back into the idea. I didn't bring the book, but one of the ideas is a guy named Stephen Meyer, Return to the God Hypothesis. I think it is. So that's a very good book because what he does is he explains how all of these science ideas are at bottom mathematical ideas. Well, every scientist needs to have a hypothesis or an idea of what God is. And so for somebody like me who's just an idiot savant when it comes to mathematics, that's what God is. And God needs to do these different functions in my universe. First thing he needs to do is create the universe, because who the hell knows how that happened? Nobody knows how that happened. You're just pissing in the wind if you do. So there's a good place for God. Well, I use God in the places where I know that I can't access. So at the very top and the very bottom, I say the biggest thing and the littlest thing, that's God. Okay, and then I say in the whole thing. So if the universe is this fractal pattern of spatial information that's arranging itself and it's doing it on the same algorithm from top to bottom, then the universe itself must be an intelligence. I mean, it's an intelligence. There's a universal intelligence. Whatever that is, it's the pattern of the universe at any given time. And the odds of a changing pattern, we just cut off. All right, well, that's probably enough. Once you start talking about God. Anyway, these are the kind of ideas that we can use as we build this new paradigm. And you can't logically, you can't talk about some of these things without just waving the white flag and saying, God, these people that say that, they've proved the non-existence of God. I mean, they're literally arguing about nothing. They're saying, I've proved nothing. No, there's something, and we don't know what it is, but we have to talk about it. Have to have a word that we can all agree will is comfy for all of us, and that's what we got to do. So God created the universe. The universe is God. Uh, he's in the top and the bottom, and he explains everything in between. Now go. Now explain your universe. Now explain your life. Now explain your math. And then, we can all meet in the middle and have a happy paradigm. So that's what we're going to do going forward.